So good day everyone, this is Isal Kuran from BSMT2B. Today we'll be discussing about the alanine biosynthesis. So as you can see, we have the reversible reaction here with these four molecules. The pyruvate plus glutamate produces alanine and alpha ketoglutarate. So it is reversible. The alanine and this alpha ketoglutarate can be converted back to pyruvate and glutamate, which will be further discussed by this video. So let us introduce first our characters in this story. Alanine biosynthesis in a nutshell. So first one, we have the alanine, of course. So alanine, it is a non-essential amino acid that our body uses as a building blocks for proteins. It plays key role in energy production or processing sugars and many more. So next character, we have the pyruvate. So pyruvate, it is the primary end product of glycolysis, as we know, and it serves as a crucial link between various energy producing pathways. So next one, we have the glutamate. So for glutamate, it acts as a vital amino acid, or it serves as a donor of its amino group in the biosynthesis of alanine. When it gives its amino group, of course, it converts into alpha ketoglutarate. So now we have our enzyme. He is alanine transaminase, and this enzyme has two tools. So the first tool is PLP, or the pyridoxal phosphate. So this PLP is a variant or a derivation of vitamin B6, specifically the pyridoxine. So it came from vitamin B6, and this molecule is very important as it serves as a medium for many biochemical reactions that occurs in our body. So what is PLP? It facilitates mostly the synthesis, interconversion, and structural shaping of our alanine. So its second tool, which is the PLP with amine group. So we will be discussing that later on how that happened. So PMP, it is the pyridoxamine phosphate. So PMP acts as an obligatory catalytic intermediate and amine carrier in transaminase mediated pathways that produce alanine. So lastly, we have our alanine transaminase. So this enzyme job is to reversibly transfer an amino group from glutamate to pyruvate and vice versa, alanine to produce pyruvate again and glutamate. So to start with, our goal is to produce an alanine, as you can see in our reaction. So in order for us to do an alanine biosynthesis, we're going to talk about these two, the pyruvate and glutamate. It says there that pyruvate plus glutamate is equals to alanine. So how can we do that? So in order for us to produce an alanine, we first pick up these two. So we have pyruvate and glutamate. Our objective is to pass or transfer this amino group to this pyruvate region here at this specific spot. This amine group shall be transferred to this spot in order for the pyruvate to be converted into alanine. So how can we do that? So that's where the alanine transaminase takes part. So alanine transaminase with his tool PLP is the main proponent of this reaction. So how that happened? So we first have the glutamate. So the job of this alanine transaminase was to transfer this amino group to this region. So we cannot transfer directly the amino group from glutamate to pyruvate because the biosynthetic pathway to that specific biosynthesis would be too toxic to our skeletal muscles. So we have to use a medium, this the PLP or the pyridoxal phosphate in order for it to transfer safely. So what does the alanine transaminase do? So the alanine transaminase picks up or removes this amino group from the glutamate. It picks up the NH2, and once the NH2 from the glutamate has been removed, it converts into, yes, alpha ketoglutarate. So the amino group, as you can see here, was being removed and replaced by double bond of oxygen. So why that happens? Because that happens because of the electron shift on the molecular structure of glutamate, which causes the alpha ketoglutarate. And then since the alanine held the NH2, he then transferred it to this aldehyde region, or the H double bond oxygen, to this PLP. So once that happened, it transfers the NH2 to this region, to the aldehyde region. The PLP is now called PMP. As you can see, the aldehyde group has been replaced by amino group. So then this ketoglutarate has been dismantled out of the active site. So we can now pick the pyruvate back. So the goal of the alanine transaminase in this reaction was to transfer this amino group from PMT to this specific area of pyruvate to convert it to alanine. So once the alanine transaminase picks up this amine group from PMP, it reverts back again to PLP. So we have the PLP again. Since the alanine transaminase held the NH2, the aldehyde group has been reverted back to the amine group has been reverted back to aldehyde group, and this NH2 being held by alanine transaminase has been transferred to this specific spot of pyruvate, which then converted into alanine. So now we have the alanine. By the help of these two, we now have the alanine. So same procedure to reverse it back to pyruvate and glutamate. We will use these two again. So how that happened? It's the same procedure happens during the glutamate period. So this alanine transaminase removes this NH2 and transfer it back to PLP, which then become PMP again, with the aldehyde group has been replaced by amino group, and then the alanine will be converted into pyruvate. Since the amino group from the earlier alanine has been removed, it reverts back to pyruvate. So we have the pyruvate again, and then the PMP and alanine transaminase picks up the alpha ketoglutarate, and the job of alanine transaminase is to give back this amino group from PMP back to the alpha glutarate here at this specific region, and it removes the double bond of oxygen and being glutamate again. So that's how it happens. And this PMT, since it gives its NH2 to glutamate, to alpha ketoglutarate to form glutamate, it reverts back again to PLP since it's lost the amino group, and it recovers its aldehyde group. And there you have it. We have the glutamate and pyruvate back, and with the same procedure we can produce the alanine, and then with a product of alpha ketoglutarate. And that would be all for my presentation. Thank you for watching.